So today we will discuss about what is the purpose of physical layer. Although we have discussed that in case of OSI model, in case of TCP/IP model, we have physical layer, which is the first layer in both cases. So one of the major functions of the physical layer is to move data in the form of electromagnetic signals across a transmission medium. So whether you are collecting numerical statistics from another computer, or you are sending animated pictures from a design workstation, or causing a bell to ring at a distant control center, you are working with the transmission of data across the network connections. So generally, the data usable to a person or application are not in a form that can be transmitted over a network. For example, if I want to send a photograph, the photograph must first be changed to a form that transmission media can accept. The transmission media work by conducting energy across a physical path. So for transmission, the data needs to be changed to signals. So before discussing about signals, as you can see in the second slide, where we have analog signals and digital signals, first of all, we will discuss about data. So like signals, we have data that can be analog or digital. The term analog data refers to the information that is continuous, and digital data refers to the information that has discrete states. For example, an analog clock that has hour, minute, and second hands gives information in a continuous form. The movements of the hands are continuous, whereas on the other hand, a digital clock that reports the hours and the minutes will change suddenly from 8:05 to 8:06. So this is digital data. So analog data, such as the sound made by human voice, takes on continuous value. When someone speaks, an analog wave is created in the air. This can be captured by a microphone and converted to an analog signal, or sampled and converted to a digital signal. Now, what about digital data? Digital data takes on discrete values. For example, data is stored in a computer memory is in the form of ones and zeros. So they can be converted to a digital signal or modulated into an analog signal for transmission across a medium. So we have two types of data we have discussed. Now the signals, that is analog signals and digital signals. Like the data, we have signals that can be either analog or digital. An analog signal has infinitely many levels of intensity over a period of time. As the wave moves from value A to value B, it passes through and includes an infinite number of values along its path. Now the examples of analog signals are radio and telephone. See here in the third slide, this is the analog signal. The second figure, this is analog signal. It is also known as sine wave. Now a digital signal can have only a limited number of, the difference between analog signal and digital is that analog signals are basically continuous signals, continuous value. Okay, like in this case, we can take points anywhere on the analog signal. It has continuous value. And in case of digital signal, we have discrete value. That is only 0 and 1. Now, if you see this signal, we have just two values. This is 1, high, and this is low, 0. This is low, 0. And then we have 1, and then we have 0, again 1, again 0. So we have just two values, that is discrete values, 1 and 0. And in case of analog signal, we have continuous value. So a digital signal can have only a limited number of defined values. Each value can be any number. It is often represented as 1 and 0. Now the example of digital signal is Morse code. Now what do you mean by Morse code? These are the type of codes which have some specific representation corresponding to each and every alphabet. Suppose for A, the Morse code is, we have a dot and then we have a dash. This is the Morse code for A. Now this dot takes 1 unit and this dash takes 3 units. Similarly, in order to represent B, the Morse code is dash and then we have 3 dots. 3 dots. Again, dash represents 3 units and these dots represent 1 unit. Now next is transmission impairment. Now when signals travel through transmission media, as you know that it is not perfect, transmission media is never perfect, so the imperfections causes signal impairment. So the imperfection in the transmission media is known as transmission impairment, and the imperfection which is caused by the transmission media to the signals is known as signal impairment. This means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. That means what is sent is not what is received. Now there are 3 causes of impairment, which are attenuation, distortion, and noise. Now what do you mean by attenuation? Attenuation means loss of energy. When a signal travels through a medium, it loses some of its energy in overcoming the resistance of the medium. That's why a wire carrying electrical signals gets warm after a while. Some of the electrical energy in the signal is converted to heat. To compensate for this loss, we use amplifiers to amplify the signal. So, suppose I have sent a signal, this is the starting point, okay, and the signal is like this. This is my signal, suppose. So this is a sinusoidal wave, or you can say this is an analog wave. Now, as it is said that attenuation is loss of energy, and due to the resistance of wire, the signal loses its energy. So suppose at this point, the signal becomes weak, and now it is this one. The signal is this one. Now what we will do, in order to amplify this signal, we will use an amplifier which will amplify the signal, and at this point I will get same signal which was here. So it will be the same signal, the strength will be same. So this device is the amplifier. And this process is known as amplification. Now the next point is distortion. Distortion means that the signal changes its form or shape. Distortion can occur in a signal which is made up of different frequencies. Each signal component has its own propagation speed through a medium and therefore its own delay in arriving at the final destination. So the differences in delay may create a difference in phase if the delay is not exactly the same as the period duration. So we can say that signal components at the receiver have phases which are different from what they had at the center. The shape of the signal is therefore not the same. So this is the effect of distortion, that your signal will be like this. The shape will change. Its shape is like this. Now next is noise. Noise is another cause of impairment. Now there are several types of noise. As you can see, we have thermal noise, induced noise, crosstalk, and impulse noise. So the thermal noise is the random motion of electrons in a wire which creates an extra signal not originally sent by the transmitter. So as you know that whenever we are talking about electricity, it means there are electrons. And in the beginning we have said that the physical layer basically transfers the information in the form of electromagnetic signal. So here also we are talking about electromagnetic signal, that means electrons. So due to the motion of electrons, an extra signal is developed which is not sent by the transmitter. So the noise which comes from this extra signal is known as thermal noise. Second is induced noise. This noise comes from sources such as motors and other appliances. So these devices act as a sending antenna and the transmission medium acts as the receiving antenna. Then we have crosstalk. This problem occurs because of the effect of one wire on another wire. So one wire acts as a sending antenna and the other as receiving antenna. So if two wires are placed close to each other, there will be a problem of crosstalk. And lastly, we have impulse noise. Impulse noise is a spike. A spike means a signal with high energy in a very short time. So this type of problem comes from power lines, lightning, etc. If you have any question up to this point, you may ask. Any point which is not clear? the type of noise. Which type of noise is not clear? All type of noise. Okay, see, first noise is thermal noise. As you know that whenever we are talking about electromagnetic signals, there is a concept of electrons. Electrons, I think you have studied in physics. You have studied in physics, okay? So due to the motion of electrons, since the electrons keeps on moving, due to the motion of electrons, an extra signal is developed which is not sent by the sender. So a noise comes because of this extra signal, and this noise is known as thermal noise. Okay. Then we have induced noise. Now since we are using different types of motors, different types of appliances in our network, so because of these appliances, some noise is induced. And this type of noise is known as induced noise. Then we have crosstalk. In case of crosstalk, suppose there are two wires and those two wires are placed close to each other. Even though there is insulation, in between we have copper wire and outside there is an insulation, but the two wires are kept close to each other, then there is a problem of crosstalk. Crosstalk means this problem you must have noticed in earlier telephone systems when we were using wired telephone systems. At that time, if you are talking to someone, at the same time you hear the voice of another person in between. So that problem is known as the problem of crosstalk. Okay, this problem occurs because the two wires are placed close to each other, so sometimes you hear voice of another person in between. And generally this problem used to come during rainy season. Now this problem is eliminated because now we are working with wireless technology. Okay. Earlier we were on wired technology. So this is crosstalk. And then we have impulse noise. Impulse noise basically comes from power lines, lightning. Okay, it is a spike. A spike means a random change in a signal which has a very high energy in a very short time. Like sometimes voltage fluctuates. Okay, fluctuation of voltage. What is fluctuation? Fluctuation is a spike, a signal with high energy in a very short time. So this is called impulse noise. So these are the three factors that affect transmission impairment, because we know that our transmission line is not perfect. So because of imperfection in transmission line, the signal impairment occurs. And these are the three major reasons. So it is clear. Now, apart from this, there are some performance factors which affect the performance of a network. These factors, as you can see, they are bandwidth, throughput, latency, and jitter. So up to now, we have discussed the tools of transmitting data, that means signals over a network, and how the data behaves. Now, one important issue in networking is the performance of the network. That means how good is it? So, an overall performance measure of the network performance is based on these four factors. The first is bandwidth. One characteristic that measures the network performance is bandwidth. The term can be used in two different contexts with two different measuring values. The first is bandwidth in hertz. This point is bandwidth in hertz, and second is bandwidth in bits per second. Now, what is bandwidth in hertz? Bandwidth in hertz is the range of frequencies contained in a signal or the range of frequencies a channel can pass. For example, we can say the bandwidth of a subscriber telephone line is 4 kilohertz. So since we are using kilohertz, that means we are talking about bandwidth which is in hertz. Now, second type of bandwidth is bandwidth in bits per second. So the term bandwidth can also refer to the number of bits per second that a channel, a link, or even a network can transmit. For example, one can say that the bandwidth of a network is maximum of 100 megabits per second. This means that this network can send 100 megabits per second. Now, second is throughput. Throughput is a measure of how fast we can actually send data through a network. Now, see, the difference between bandwidth and throughput is very small. You have to make it clear that there is a difference between bandwidth and throughput. As per definition, they appear same, but actually they are not same. Now, let's take an example to specify the difference between bandwidth and throughput. Suppose we have a link with a bandwidth of 1 megabits per second, but the devices which are connected to the end of the link may handle only 200 kilobits per second. This means that we cannot send more than 200 kilobits per second through this link. So in this example, 1 megabits per second, this is the bandwidth, and 200 kilobits per second is the throughput. Okay, let's take another example. Imagine a highway which is designed in such a way that it can transmit 1,000 cars per minute from one point to another point. However, if there is a congestion on the road, this figure may be reduced to 100 cars per minute. So the bandwidth is 1,000 cars per minute and the throughput is 100 cars per minute. This is clear? Is this difference clear? Yes, okay. Now next is latency. Latency means delay. So it defines how long it takes for an entire message to completely arrive at the destination from the time the first bit is sent out from the source. Now, if you will see your slides, you will find out that there is a formula to find out latency, and that formula is made up of 4 components. They are propagation time, transmission time, queuing time, and processing delay. So latency is equals to propagation time plus transmission time plus queuing time plus processing delay. So there are some questions which are based on latency, throughput, bandwidth, frequency. Try to solve these questions, and if you have any problem, just let me know through email. And inshallah, in my next face-to-face lecture, I will give you some examples, and you will find it very easy to solve these questions based on these concepts. So for a time being, just remember that latency is the delay which defines how long it takes for an entire message to completely arrive at the destination from the time the first bit is sent out from the source. And lastly, we have jitter. And this is another performance issue that is related to delay. Now we can roughly say that jitter is a problem if different packets of data encounter different delays and the application using the data at the receiver side is time sensitive. For example, if we are using audio and video, then if the delay for the first packet is 20 milliseconds, for the second it is 45 milliseconds, and for the third it is 40 milliseconds, then the real-time application that uses the packets will endure jitter. So this is the problem that we face in real-time applications like audio and video applications. Now if you have any question, you may ask. If you have any question up till now, you may ask. Okay, this is clear. And now one troubleshooting tip for those who are working as a network engineer or IT professional. Whenever there is a problem in a network, the first troubleshooting tip is look at the physical layer first, because more than 50%, around 60% problems occur in physical layer only. So this is a very important troubleshooting tip, that physical layer first. So with this we came to an end. This is the reference book for this subject, data communications and networking. That's all for today. I'm still here until 9. If you have any question, you may ask. Inshallah, we will see you in next face-to-face lecture. Till then, take care all of you. Assalamu alaikum. Yes, Munera. What's your question, please? It's not clear. Example of what? Yes, Munera, are you with me? Example, calculations. Calculations like? frequency, bandwidth, latency. These examples you need. Examples of latency, frequency, bandwidth. This is what you are asking for? Okay. Okay, do one thing. This week, go through your book, go through your slides, try to solve the questions that are given in your book, examples that are given. And if you have any problem, just mail me, let me know. And inshallah, in my next face-to-face lecture, I will take some of the examples and I will explain it to you. No problem. But first try to do it yourself. Still, if you will have any problem, I will discuss it in class. Is it okay? Okay. Okay, no problem. Just go through it. Okay. And still, if you have any problem, we will discuss it in virtual class. In my virtual class, you will be there next week. Yeah? Okay. So in virtual class, we will discuss it. Inshallah.